Hello, everyone. Thank you for being there. And we will talk about 3D. So if you want to talk about 3D, you're in the right room. Else, it's not the right place. We will talk about 3D and JavaScript and all wonderful things we can do with a 3D engine. My name is David Catuhe. I'm working for Microsoft. I'm responsible for relationship with web developers when it's about IE and open web standards. But today, I would like to talk about something different, which is not really directly related to IE. I would like to present you Babylon.js. So Babylon.js is an engine I'm working on my spare time. It's not something affiliated to Microsoft. I'm working for Microsoft, that's the story, number one. But on my spare time, weekend and nights, most of the time, I'm working on this specific baby, Babylon.js. Some numbers for you guys. We have pretty good traction all over the world. It's a big chunk of code that already shipped. We work with TypeScript, and I have a session this afternoon about how we work with TypeScript in order to create this specific framework. So I think it's at 4:30 in the same room, or in 130, in fact, actually. We have a lot of things. Everything is free, available, Apache 2. Feel free to use it. And the main thing I would like to say about Babylon.js is that we created it with simplicity in mind. Simplicity is the guideline, is the foundation of what we want with Babylon.js. Dealing with WebGL could be, most of the time, is not that easy. It's a really low-level API. You deal with the GPU, you are near to the metal, and sometimes it could be really hard to, for instance, use mathematics or shaders or things like that. We decided to create Babylon.js in order to allow all web developers to create 3D world without having the burden of dealing with all the internal plumbing, right? We did that with simplicity and performance in mind, and if you want to use it, the best starting point is Babylonjs.com. You will find here all the demonstration we have, and obviously the documentation, the wiki. I spend a lot of time writing documentation. I hate reading documentation. I know that you guys also hate that. And we try to develop another way to learn Babylon.js without having to read the documentation. I will get back to that quickly. If you want to use it, that's pretty simple. Just include the script itself, Babylon.js. That's simple. No need for anything else, just your favorite browser. The way we think about Babylon.js is a set of tools that you can use, and all these tools have to discuss with the GPU. The man in the middle in this exercise is the engine itself. So if you want to discuss with the GPU, you need someone that is able to create shaders, that is able to copy memory from the CPU to the GPU, and this guy is the engine right there. Then it's a scene graph, so you will deal with camera, light, meshes, 3D object if you wish, and because we are dealing with 3D, you have to be able to deliver a maximum frame per second. And this specific job is handled by this small function, run render loop. We have plenty of features. I spend a lot of time adding new one. We have a lot of interesting and cool stuff. And 1 hour is not enough to present you everything. So if you think you need something, first step, try to find it into Babylon.js. If it's not there, send me a mail. I love challenges. Best way, I think, to discover a framework is to actually use it. So let's start. I have here, OK, disclaimer. I'm working for Microsoft. I use Visual Studio. I'm on Windows, and I will use IE. That's a big bunch of stuff for you guys. By the way, Babylon.js is a JavaScript framework. It should work, obviously, anywhere else. I mean, on your MacBook, on Chrome, on Firefox. I deeply test that everywhere. It works everywhere. Obviously, I can show you, I can use Sublime Text on macOS, but it should be weird, mainly for Microsoft. So I use these tools, which are great. Let's just add a new page to this project. So the project is a simple project. It's a website, nothing special. This page will be called startup.html. OK. Do you want me to zoom perhaps a bit? Sounds OK? Right. OK, very first things to do, we need to include a reference to Babylon.js, right, guys? So let's create a script. src is equal to http://www.babylonjs.com/
You would type on src.
src, absolutely. And you can see that Visual Studio tells me it's not right, guy. /Babylon.js. That's it. You're ready to go. Second thing, I will create just the DOM object I need, which is the canvas itself. Let's call it render canvas. No need for more. The canvas is where everything will be done for the 3D stuff. It's exactly the same story when we have to deal with 2D. We use a canvas with specific APIs. It's exactly the same story is here. WebGL will work into a render canvas. Some style, just to be sure. And I will be a bit lazy. I will copy them from here. I just need a full screen canvas, nothing else. Okay, I don't want to deal with anything else. So I have a render canvas, full screen, no touch action on it. I will control the touch by myself. And we're ready to go. Very first step, we need to create an engine. So var engine is equal to new Babylon.engine. The engine itself will work and will require a canvas and a canvas, sorry. The canvas is here. Document.getElement by ID, render canvas. Okay? So the canvas itself, and the second parameter is about do I want anti-aliasing? Okay? Yes, I want it. Interesting thing is if you want anti-aliasing and for instance you are running on a phone where anti-aliasing is not supporting, that's not a problem. It will revert back to false. That's okay. Once the engine is created, I have to create a scene. The scene is the container. Everything should live into a scene. You can have as many scenes as you want. So let's create a Babylon.scene. The scene just needs the engine to work on. The engine is the way to communicate with the GPU. Anyone needs an engine, okay? So the scene will have a link to the engine to be sure that it could send an order to the GPU. Once the scene is created, I will have you, me. Point of view, the user, the player, whatever. When we work with this kind of concept in Babylon.js, it's always related to a camera. The camera is the point of view, okay? So let's create a camera. This camera, we have a lot of different cameras. I will get back to this after. Here, I would like to create an arc rotate camera. This camera is a specific camera that lives in a sphere around a specific point. It's extremely useful if you want to present one single object to your users. So you have just one single object in the center of the screen, and the camera will be able to rotate around using touch or the keyboard and the mouse. So it's pretty interesting. It's not a first-person shooter camera. You won't be able to wander around, but it's more something used to present a single object. Okay, so this camera has a name. Let's call it camera, or cam. And I need two angles. The first angle is this circle on a sphere, and the second one is this one. So for now, let's say 0 and mat.p over 2. You can say 0, 0, and then move with the touch, for instance. And I will also need a radius, the radius of the sphere, my distance between the center of the sphere and where the camera is. So let's say 10, for instance. The target, the center of my sphere, center of the world is 0, 0, 0. So let's use Babylon.vector3.0, which is 0, 0, 0. And finally, the scene where I want to put my camera in. OK? With that, I define the point of view, all the metrics required to project from 3D to 2D, everything related to touch. I want to handle my position, everything related to keyboard and mouse, just one line of code. Then I need a light, because without a light, everything will be black. So let's create what we have different kind of light, obviously. The easiest one is the hemispheric light. It's like the sun. It's a light which is global everywhere that works well with no specific information required. So let's call it EMI. The direction to the sky, so it's up. We are using X, Y, Z word. It's a left-handed word, okay? X, Y, Z. If you do that with your fingers. So where is the sun? The sky, sorry. It's a vector 3 this time. So up. Up means 0, 1, 0. Okay, X, Y, up, this one, and Z. And finally, the scene, same story. Every object has to be attached to the scene. So you have a camera, my point of view. I have a light to shine all my scene, and I just need one object. So let's create what you want, sphere, box, sphere. No, box. A sphere is strange when you are using an arc rotate camera because you are rotating around something which is already round. Sounds like it, nothing is moving, by the way. So let's use a box. Dot mesh. Mesh is a technical term for 3D object. And I want to create a box. OK, so the box has a name. For instance, box. A size, say 3 by 3 by 3. And you get it, the scene. OK? I have defined, in my point of view, the scene, the light. I just need to define the color of the box itself, the material. We call that a material. So let's create a material. The material is exactly the entry point for shaders. This is where all shaders are defined. We have a specific standard material for Babylon.js where every shaders are included. It's a big, huge shader which can be optimized by Babylon.js to just focus what you want. For instance, if you want different color, different texture, etc., it will be compiled for you just to be sure that the shader only targets what you want. It's not a big shader with a lot of if inside. It's really a real-time shader that will be compiled just in time for you guys. So the GPU code will be exactly what you are asked for, okay? Without having to write shader code, obviously. So let's call it mat, and we will attach it to the scene, same story. So box.material will be equal to material. And we can define, for instance, that the diffuse color, the basic color of the object itself, diffuse color is red. Sounds good? Color 3.red. RGB, so it will be 100 if we want to talk about RGB. So we defined our scene. The only missing thing right now is that I want to render that as fast as possible. And for that, we have the specific run render loop stuff, which take an anonymous function. And I just ask my scene to render. That's it. Obviously, you can add specific things here. For instance, let's say I want to play with my box on every frame. I can say that box.rotation, sorry about that, dot y plus equal 0.001. So on every frame, the rotation we've just slightly moved, but it will create an animation. So let's see that here. Wow. Isn't that cool? The only thing I forgot to do here, I want my camera to grab all the events. So I have to call attach control and say, here is the DOM object you want to control. So by just doing that, this time I can control with the mouse, but obviously with my finger. OK, if I have the touch here, see, I can pinch zoom if I want. The camera will handle everything related to the specific behavior of this specific camera. Here it's a rotation, arc rotate camera, so I can rotate. The cube is slowly rotating on its own axis, but we can also rotate around. Does it make sense? Cool. Going further, obviously, we can have different kind of objects. So here, same story. I have my scene, my camera, I attach my control, I create my light. And it's just for showing you basic shapes we have available out of the box. For instance, we have box, sphere, plane, cylinders, torus. The torus knot, which is a double or triple torus, it's the equation of a torus that is, it's really interesting. You will see that. We can also use lines. And object can be moved, rotate, and scale by just playing with the rotation, position, and scaling property. Okay? I have my render loop here. And I just play, for instance, with the knot on the rotation. New feature here, we can also ask the rendering to always remain full screen, meaning the real pixel size. So for that, every time the window is resized, you just have to call engine.resize. So if we watch that, this is the same result. We have a plane, we have a torus here, and my lovely torus knot, which is cool. Now, yes?
Can you change line thickness and style? So if you want a dotted line?
If you want to change the weight of the light, we can do that because it's a cylinder, but we cannot apply some kind of dot on it. I mean,
okay. So that's rendering it as a cylinder?
Yes, it's a cylinder. In this case, it's more, because the weight is 1, it's just a single line, really. So it's some kind of weird triangle with 2 points at the same place. So we really have a line. If we want to do what you mentioned, we could use a texture to apply some kind of...
so the dotted pattern?
Yeah, dotted pattern on top of it. Yep.
Okay. Thank you.
As you can see here, my torus is not really well designed because you control, when you create an object, the tessellation. So if you want a lot of vertices or if you want just a few of them like this, you can control that. Here, when I create my torus, I say that I just want the tessellation of 10, but if I want something really well defined, I can use 32, so a lot more tessellation. And the same scene will look like now, if we are looking at the torus. Not the same. Did I save it? Yes. Cool. As you can see, the torus is far more better right now. Obviously, it's more expensive to render. We have to deal with that. Yes?
Can you pipe another data source into the camera rotation or control it programmatically?
Absolutely. You can control whatever you want. We have a model where you can do two things. You can just play with the parameters themselves. For instance, your camera has a property angle, alpha and beta. You can play with that if you want to control where the camera is. You can also obviously play with the position itself. So in my case here, I can force my camera to go somewhere just by saying camera.setPosition. Okay? But I can also play with alpha and beta. You can do whatever you want. And there is another way, is by inheriting, extending the camera itself. So we did that, for instance, we have an Oculus camera. There is two children for this Oculus camera, one where the control is done by the keyboard, and one where the control is done by the gamepad. It's the same code, you just add a few lines of code by just inheriting. We try to make everything simple to use, but we also want to never block you guys if you want to go deeper. Open the box and just play with something under the hood. That's every time it should be possible. If it's not, I will fix that. Next step, we saw that we can create some kind of basic shapes. We can also here create different materials. So I create 6 spheres, okay, all the same. Different position, obviously. I also create a plane, and then I play with the standard material. The standard material is what we call the Uber shader. It is able to render almost everything, and because of just-in-time compilation of the shader itself, you will be able to get maximum performance because we try to never use if into the shader itself. For instance, we can say, hey, if you want diffuse color, then I will do this code. Else, if you don't want diffuse color, but instead diffuse texture, I will use this code. This is not how the shaders are working with Babylon.js. We have a full shader with all options, and when you set some options, we remove the code itself, and we send that to the compiler. So every time shaders are split out, they are exactly what you ask for. Not the biggest one, but just the smallest possible for you guys, with all the options you ask. So here I have material 1, wireframe. I just want to see not plain plain triangle, just the line. Then I want, for this second one, diffuse color red with alpha transparency to 0.3. I can also play with diffuse texture. Instead of having a plain color, I can use a texture. I can also play with the position of the texture on the object with UV offset and scaling. I can also play with texture, this time a PNG, so with alpha information on it. And I want to use this alpha as a way to remove pixel. I will show you that. For instance, when you want to draw a tree, and you want to draw the leaves, it's far easier to use just a plain rectangle with a texture on it to remove pixel where there is no leaf, instead of using a real geometry where you want to draw a leaf. Then we can control backface culling or not. And the result looks like this. So just here, we have the wireframe, red with alpha. Then here I have a different version of the texture with different positioning with UV offset. The interesting one is this one, because here we can see through the object. So the leaves texture allow me to remove pixel, discard pixel, so I can go through the object. So it's giving me the impression of a really complex geometry. And obviously, because I can control if I want to remove backface or not, I can also have backface removal to off, disabled. So here I can see the backface of this specific object. Each time I do that, a new shader is compiled with exactly what I need. OK, then.
The leaf, so it just has transparent pixels.
Yep. Yeah, there is two kinds of possibility here. We can do alpha testing or alpha blending. Alpha testing means for a value of alpha between 0 and 1. For instance, if the alpha is 0.3, it's under 0.5, so the pixel will be discarded. Alpha testing just use a threshold value. If you're under this value, pixel will be discarded. If you are over this value, we keep the pixel. Alpha blending is about mixing, blending the current pixel with the previous one, using alpha as a threshold value. Okay? We can do both. Yes?
Do you have any events with this? So like a message created with an event?
Yeah, we try to add event for almost everything. So you have an event when an object is created, when you have an event when an object will be rendered, after rendering, when the collision is detected. We try to. And if some events are missing or you find some new event useful, just send me a mail.
Do you have any way of rendering the render targets at the moment?
Excuse me?
Do you have any way of rendering render targets, having your import render?
Yep. We have render target possibility. Simultaneously, you mean? Or simultaneously, you want to render to... Yes. No, this is not supported by WebGL. So you have to render one by one. So if you want to do some deferred rendering or things like that, this should work, but it will be slow. Right. We have everything required, but WebGL right now, version 1, is not enough powerful for that. OK. We also have really high-level objects like, for instance, particles. If you want to deal with particles, 3D without particle, it's not 3D. We need particles everywhere. I find that so funny to use. So here, same story. You can create a particle system, attach it to the scene. I define here that I just want no more than 2,000 particles for this specific system. And then you can define a texture and play with a lot of properties, where who is the emitter, what's the size of the box, the color at the beginning, at the end, the size. So the value will be randomly picked between these two values, the lifetime, emit rate, how many particles per second, what do you want as a blend mode, is there gravity, what's the direction at start, etc., etc., etc. But just by doing that, by defining what you want, you can get these kind of things. The emitter is the box is animated, and it will spit a lot of particles.
Does it have sound as well?
Yeah, incredible. I control the sound of the room just to give you the impression. Yeah, this is important for me.
You emit from just a point, or can you emit from a sphere or a plane?
Yes.
A line?
There is a basic behavior, and if you want to control more precisely how particles are emitted, you can provide your own anonymous function. And then every time a new particle should be emitted, we will call your function to understand where do you want to put the very first value. Same thing for every properties, color, position, speed. Everything can be controlled by you guys. So we have a really basic set of behaviors which are all available to update if you want.
So you supply callback?
By callback, absolutely. Yes. So if I want to, there is two ways to do that. The engine itself knows the frame rate, so you can ask engine.fps. That's easy like that. When I'm working with IE, Shift Control U gave me here the FPS. But engine.fps do the trick if you want. Okay. Then, shadows. Obviously, there is shadows using shadow map. So shadows are supported. All things are working. Here, I create a light, which is a directional light this time. So direction, where the light is going to. My light has a position and an intensity. And I create a sphere exactly at the same place, just to show you where is the light. Light by itself is not visible. We can see object lighted by lights, but we cannot see a light directly. So that's why I'm using a sphere just at the same place. Second light here with a second sphere. I create a ground, and this time I'm using a funky function called create ground from 8map. So you give an 8map. 8map is this kind of texture. Black will be flat. White will be some height. Okay? I want so to use a plane which will be deformed by this 8map, a standard material, and that's it. Then I create a torus. I like torus. And I use one object called the shadow generator. The shadow generator will work with a light. So it will use a texture of 1000 by 1000 because it's shadow map. So we need to render the shadow into the texture and then use this texture with our shaders to simulate the shadows, okay? So I will have two shadow maps, one for the first light, one for the second light. We have different kind of smoothing and blurring effect applied to shadows to be sure that shadows are good looking. And we just have to say, okay, ground will receive shadows. So just by saying that, ground will know that every light should give it some textures used by the shader themselves. Then I will just have to say, okay, let's rotate the torus and move the torus on a circle, and that's it. And the result is the following one. So two lights, which are here on the sphere, and we can see, so my ground was a flat mesh deformed by the 8map itself, and I have two lights with two shadows.
Any particular program to generate those type maps?
No, we do that. Everything is done, it's homemade. We try to be sure that we have no dependency on whatever. So if you want guys to use that, there is no...
I don't know, but I mean, when you create something like this, is there a particular program that you use to create a frame?
You mean the shadows or the 8map?
The image for the logo.
Ah, the image. No, I just did that with paint. So, but you should use whatever you want. You just need some black and white texture. Yeah, I'm not a really good designer, by the way. It sounds like a mountain, so I was really happy. OK, guys?
Can you make the shadow soft, the edges?
Yeah, this is because we use different kind of blurring effect. We have variance shadow map, and we also have Poisson shadow filtering. It depends. We try to find some ways to filter the textures, the shadow map itself, just to get soft shadows. That's not easy. OK, going back to slides. As I mentioned before, I'm like you. I hate reading documentations. Each time I want to learn a framework, which is often when we deal with JavaScript, I hate using documentation. That's a good thing to learn. I agree with you. But we try to create 2 tools for you guys just to allow you to learn Babylonjs without having to read some documentation. The very first one is the playground. So let's go here on Babylonjs.com. You will have here a link. Try it. OK? If you click on it, I'm pretty proud to present to you for the very first time the V2 of our playground. This V2 has something really exceptional, and I fought a lot with a lot of people to be able to show you that. We have, into your browser, Intellisense. So you can discover all the API by just playing with it. So on the left side of the screen, you can play with Babylonjs. On the right side, obviously, Babylonjs will render what you want. And to learn without having to read the documentation, you just have to play with the Intellisense. So what can I do with a scene, for instance? So I just have to type scene dot. There is some features that as you can see. I can, for instance, change the clear color. Ah, yeah, that's a good idea. Clear color. So I need new Babylon.color3 here. Dot R. No, that's what I want to do here. So Intellisense allow me to have these small hints. OK, you need RGB. Cool. So the background should be like this, for instance. When I hit run, woo, that works. I have to show you that, right? I get your point. Let's try with Chrome. So, sounds like the same thing. Woo. Obviously, I can do the same. I have Firefox, Opera, and Maxton. It works everywhere. We try hard to be sure that we are talking Microsoft Change. We are talking about web standards, so I try to work with web standards. So yes, it works everywhere. Let's use Chrome if you want. So you have some kind of samples here. You want to discover a basic scene or basic elements, and you can play with them live. You can want to play with different information like rotation and things like that. Camera, like blah, 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 blah. I can show you, for instance, height map. We just showed before. So this time I'm using some kind of wall map as a height map, etc. If you want to create your own application, you can click on the new. Or if you just want to edit some previous version, like, for instance, I don't know, basic element, and you find that the torus is not well defined here. So instead of 10, you want 32. You can run that. And if you want to be able to use that directly, you can just click on Get Zip. And it will package for you everything required. So a page with all the information, everything is already set up for you. You just have to copy-paste that into your application. That works. Same story. You want to share that with your friend, or you want to discuss about whatever. You just have to click here on Save. And it will generate for you a unique URL that I can use, for instance, with Firefox. And as you can see, I have my updated version. You don't need documentation. No, yes, you need it, but for very specific features. We try to write a lot of documentation, but learning a framework from my point of view is really about experimenting it. So yeah, feel free to experiment it. You just have to go to babylonjs.com/playground. Second feature I want to show you. The first one was about learning Babylonjs itself, but we can also allow you to create your own shader. You don't want to use our Uber shader, you want to do some specific, really hard to understand stuff. You can have the control over the shader itself. For that specific point, we have just here the CYOS. Create your own shader. So we have this time different kind of object, torus, sphere, ground. You can here write the vertex shader and the pixel shader you want to use. Let's use some simple basic shader, okay? This shader is extremely simple. So I have my vertex shader and my pixel shader. Perhaps I want to do some black and white stuff. So here is the modification I want to do, doom. And I have some basic black and white shader with a texture, okay? Once you're okay with that, you can use the zip function here. And we will ship for you a version with the texture required, all the text into, let me export that into my desktop. Sure. Yes, open, edit with Word is not a good idea. So you have all the style, the script, everything, and you also have all the shader inside your application to show you how to use that directly. It's just one single HTML with the shader inside. To do that, I have also a simple sample here, which is the 5. So you have different ways to use shaders. You can use, for instance, script code, where you copy-paste your shader code, and with just a different type. So it's not JavaScript, obviously. It's something I'm creating for you. It's vertex shader, for instance. Same story here. I have my pixel shader. And instead of using, so I create my camera, my scene, everything else. But instead of creating a standard material, this time you create a shader material. This material will be also applied to mesh and whatever. It's exactly the same thing. But this time, you will be able to say, OK, this is the vertex code. This is the shader code. Here are the attributes I need. Here are some texture for you, so you can send value to your shader once it's compiled. This is your own shader. And obviously, the sphere.material, this time won't be a standard material, but will be a shader material. Does it make sense? So you have control even on the rendering itself. You can obviously use the shader, which try to do everything for you, but you can also do what you want. OK? And if you want to learn, just try to use CYOS.
How do you pass the attributes and the uniforms to the shader?
The uniforms, for instance, here, my texture, so sampler, but it should be also here, Amiga material.set float, color 3, whatever. We have all the opportunities to send directly uniform from your JavaScript code to the GPU. And I take care of everything for you. I don't send everything each time you ask me. I create a bunch of code to be sure that it will be sent the most quick way, let's say. I try to just let you know what you want, and I deal with everything else. Right. But we are not alone. And we need 3D artists. I need 3D artists. To be honest with you, I'm not really good in 3D design. I know how to create sphere and box by using math function, but that's it. I don't know how to create a word. That's why we decided to work with 3 different ways to import 3D assets. The very first one is using Blender 3D. We have a plugin into Blender 3D, so let's launch Blender. So into Blender, you can create your scene. I know how to create a monkey head. I like that. Sorry, I'm not a good user of... Yeah, I have my monkey head. I'm so proud of that. I have a camera. I have a light. Sounds good. You can just use export Babylon.js here. I wrote a Python script to do that. You just have to put that into the plugins folder of Blender. That's it. And let's put that into the desktop itself. And it should add generated for me some kind, yeah, untitled.babylon here. Okay, sounds good. I also generate for you guys a log where you can see that I exported this kind of information. Beware, material have no information for texture. That should be okay for you. I just want to let you know. But it was great. It was really great, but it was not enough. Because when 3D designers want to work this way, they want to be able to test using the engine itself. So before they had to send this kind of file to the developer had to try to load it, etc. We decided that it's just too much. So going back to the site itself, you are here, the sandbox. The sandbox uses HTML5 drag and drop stuff. So if you can just grab and drop your .babylon file here, designer can dynamically test live the result of what they exported. And that's cool. I have my scene, my monkey head. Sounds good. Okay? Blender is a great tool, but we worked with Ubisoft to create Assassin's Creed race parade for the web. And they told us, yeah, we love a lot Blender, but we are working with 3ds Max. So we decided to also support 3ds Max. 3ds Max, I will do an incredible demo. Look at that. Tuk. I asked Michel Rousseau, which is a friend of mine, who is a friend of mine, to create for me a real 3D demo. Everything in 3ds Max, okay? And I developed here a small exporter. So let me put that into my desktop and say, can I create a folder here? Let's call it test. Into test V8. Okay, I know this is a V6, but for some reason I thought it was a V8, so everything is called V8 right now. I'm sorry about that. I'm a developer. I'm not. I don't do anything else. So if I click here to export and run, this is the just one click to test feature we added to 3ds Max. Everything is designed to 3ds Max. At the end, I want to test that with Babylonjs before sending all the assets to the developers. Just click export and run. We generate for you guys a lot of information. The log is OK. We launch for you a local web server. And directly from 3ds Max, files are served to your favorite browser. Here it's IE, but I promise you this works with everything else. And this scene that was designed for 3ds Max is working perfectly well in real time with shadows, animations. And you can discover that the V6 is working like this, which was really interesting, by the way.
This is an i6.
I know that. Someone told me it's not a V, it's something in, I don't know what. Yeah, it's an engine, OK? And I find that pretty interesting because my engine is rendering an engine. It's like a meta engine, you know? I like that. So,
V8 folder in your Visual Studio was referring to this, not to V8 JavaScript 20.
Sorry?
You have, in your Visual Studio solution, you have a folder called V8.
Yes, I know. It is this one. It's not a V8, it's not even a V6, but yeah, because it's funny, we kept that. So, your designer can be able to work, obviously, with these different tools, but also we support OBJ, FBX, and Collada if you want. For that, we have an online converter. So if you are not able to use Blender or whatever, and you just want to use your asset, we have an online converter here. I think it's converter. .html. Yep. So you drag and drop your file here. We have something running in Azure that will translate that into our format and give you the result. Okay. So it's not my favorite way, to be honest with you, but sometimes we have nothing else. Yes?
Does it work with any 3D cameras, like a Kinect?
You want to control the 3D with your Kinect, right?
Import pictures from it.
Yes. As long as you use the format that we are supporting, like FBX, DAE, OBJ, or anything else supported by Blender and 3ds Max, which is the right thing, yes, it works. You have to be able to, in a way, find a way to enter in our pipeline. 3ds Max, for instance, has a huge quantity of different supported files. So most of the time we use Blender or 3ds Max to import some weird format and then split out the Babylon.js format. Okay? By the way, the format itself, we have 3 different formats. The first one is pure JSON. So for instance, this demo, let me show you the demo. If I can just leave that. So, yeah, sure. This specific demo here, only the scene, so no texture, just the JSON description file of this specific scene, weight 22 megabytes when we are using pure JSON. But because I set up my server to send JZip data, it's just about 4 megabytes over the wire. Okay? Then we have another format, which is incremental format. When you want to create not just a single room, but for instance, a city, you cannot afford to load everything. That's not possible. So we have a specific format called Babylon.incremental, where we load things as soon as the engine can have to render them. Okay, so you are in a room, we will load the room, then you go through, for instance, a door, and then the next room have to be rendered, then we will load the object in the next room, etc., etc. Okay? But it's still pure JSON. So in this time, it's same size, just we remove object from the main catalog file, and every object has its own file. And finally, we have a binary format, where we have a catalog defining the scene, but where each object is saved using a binary format. We just have to load that and put directly into memory. Okay, it's a float32 array that we can just load from Etcher and sending directly to the GPU. This is by far the most efficient way to save and load our scenes. We have this format. It's available for you guys. You can choose what you want to generate.
So you export those from Blender?
Blender, 3ds Max, whatever. Okay. You want to know how to load data, and that's extremely simple. You want to import a mesh. So there is 2 ways. You can want to import just a specific object from a scene or all the scene. Okay? If you want to just import, you have to use Babylon.scene_importer import. You can give the name of the object here. Without name, I import all the object, which is like loading a full scene. Where is the scene? And the name of the file. And once everything is loaded, I will receive here a callback, and I can do whatever I want with that. So if I just run this specific one, yes, that's me from the inside. And as you can see here, I just loaded the skull itself. It's just one line of code, and when everything is ready, we call this specific function. You can also do that for full scene this time. So I want to load in split.json here this incremental scene. So we can go here and see how it looks like. Mainly we have textures, okay? Then we have the scene itself with different mesh data. So every single object has its own file, so we can load them when we need, and not just loading everything because it's just one single file. The result is like this. Okay, as you can see, things are loading, and when I will move, it will be quick, but check. Oh yeah, loading extremely quickly because I'm local. So this scene, with collision system, everything, I can go upstairs, whatever, playing like with my first-person shooter camera. Everything that you see here is just that kind of code. I load my scene, I attach my camera, thank you, everything is ready for you guys. Obviously, you can go through all the tree, find the object, play with their position, do whatever you want. That's just.
Let's say I have my own data, not in your formats. How can I create binary of that Babylon?
If you want to create your own Babylon format, you mean? You have to use the exporter we have, for instance, in Blender or 3ds Max. But we also have a documentation where we explain how the binary format is created. But by the way, it's extremely simple. We just take a float32 array, and we split that to the disk. So we will be able to load that immediately. Quickly, we have tons of camera. We have camera with touch, device orientation, virtual joysticks, anaglyph, VR. We are supporting Oculus Rift, WebVR, cardboard, anything that you can play with your phone or whatever. We're also supporting gamepad. It's just extremely simple to use. You just have to change the camera when you create the scene. For instance, here. This scene, I'm loading my scene and I want to use this time Oculus camera. It's just new Oculus camera. Here's the position. If I show that, it will load the, oh, interesting. It won't load anything. Oh, yes. I changed the folder. Just yes, obviously. And I have no Oculus, but you can imagine that I can just put the Oculus Rift on my head. And because we are using device orientation, we can just control everything without no plugin at all. And you don't want to use Oculus, you prefer using, I don't know what, virtual joystick? Sounds good for you? So virtual joystick is mostly for fun. It's when you can use your two thumbs like joysticks. That's OK for me. You just have to change the line where you define the camera. Yep, let's go. Look, my screen. And OK, I'm just not really a good. Kids are far better than me doing that. I don't have the, I don't know. OK, and it's the same story with everything. You want WebVR, it's just WebVR camera. That's it, and we take care of everything for you. Okay, same. I already show you how to use collision. You have nothing to do, just load a scene with collision. But if you want to use collision, that's extremely simple. You just say, hey, I want collision on this specific object. That's it, and the camera won't be able to go through it because of the collision system. I want to show you just quickly a demonstration about the engine, the physics engine we have inside Babylon.js. So let me just change that to go quickly to this demonstration. No, thank you. That's not what I want. So here, I will load always the same story, the split scene, okay? But this time, I will call enable physics. We have different plugins. We have plugins for Canon.js. We have plugins for Oimo.js. We have plugins for Bullet. We have different plugins. So you just have to choose which physics engine you want to use inside Babylon.js. So here I'm using, for instance, Oimo. And then I just go through the scene, and all the objects that can be used for collision will also be used for physics. And then I have a tool to generate. When I touch the S key, I will just split out a sphere with a physical impostor on it. So this sphere will be controlled not by me, but by the physics engine, okay, with a mass of 1. The result is this scene, always the same. But if I hit S, I can split out a lot of sphere. And obviously, this sphere won't go through my object. It's physical. I can kick on them. And I think it's B for box. Yep. Here, it's a tool that I'm using to debug. So I can see the box surrounding my environment to be sure that I don't have a hole where my sphere can go outside. So here, I can remove that just for debugging, and it's awful, by the way. So it's just physics everywhere. I can spend hours doing that. It's on your browser, and obviously it works on Chrome.
For the physics, does that get checked on a key animation frame, or request animation frame, or how often?
You can control. Most of the time, I prefer using a web worker for that, so it's living its life at the rhythm you want. But if you want to be perfectly synchronized with your animation, that's an option. You can do that. You decide most of the time.
The particles collide as well?
Yeah, the particle right now does not collide. That's more complicated because most of the work for particles are done in the GPU. So animations and things related to particles are in the GPU. I have no way to really do physics in an efficient way. Right now. We are thinking about that, to be honest with you.
In your samples, you put meshes under scene. Can you build any structure of scene graph?
Obviously.
What would be the object?
Excuse me?
What would be the object?
We have the scene itself, and then, for instance, a mesh can have a children. This children can have another children. It's just always the same object, but in a hierarchical way. Does it make sense?
You have group objects?
You can have group object if you want, obviously, and it's still a mesh, which just is invisible and with a lot of children. It could be invisible or not, by the way. You should. Sorry.
Can you render scene to texture so you have like picture to texture?
Yep. We have a specific texture by default is about just file texture, but we have also mirror texture if you want to use a mirror, which render the real scene. And we have render target texture where you define, okay, this camera won't render to the screen, but this texture can be used then by the shader themselves. Yeah, you can do mirror of mirror with a certain limitation, but yes, you can do that. For instance, I use Chrome. Just for you guys. This demo is about rendering texture, because in the center, I'm rendering the scene, but just for the depth point of view. You will see, once it's loaded, yep. This is my scene with a skybox. We support skybox, by the way. And in the middle, it's a texture. It's a render texture on a plane. And I render with a specific custom shader I defined. And instead of rendering the color, I'm rendering the depth. OK? Could be useful. Oh yeah, I have to finish. Okay. Just last, very quick things. You can, with exactly the same code, generate Windows 8 and Windows Phone 8 application. Just because Visual Studio allow you to create native application for Windows 8 and Windows Phone 8, I can, for instance, here use just this code and launch that on my Windows Phone. And it's an application. Yeah, thank you. My device is connected. No, it's not connected, right? Let's try again. You should have to believe me, else device cannot be found. Thank you. I really appreciate. OK. By the way, you can come to see on my phone, just by using this code, I can do that for Windows 8, by the way. So it should also work. This time, same code, and I'm generating a Windows 8 application that you can, for instance, put into a Windows Store and earn money with it or whatever. No additional code. It's just a container around your own existing Windows HTML code. So that's pretty interesting because you can, in this way, go into a store. OK? And obviously, you have to define a game using that, because just visiting a virtual museum could be interesting, but I'm not sure you will earn a lot of money with that. Yes? Excuse me?
Do you have any profiling tools for this Babylonjs?
OK, profiling profiling tools into Visual Studio, absolutely. We and even into Chrome or Firefox or IE, we have F12 tools that allow you to profile. One of the next features we will add is what we call the Scene Optimizer. It will be a tool that live in real time, we'll try to reduce texture size or try to remove options for you just to be sure that you can keep 60 frames per second. It's the tool we are working on. Everything related to profiling, memory profiling, and performance profiling can be done into IE or with Visual Studio. We have a lot of profiling tools that you can use to test and try to find the best way to do what you want.
If you were to design a game, how would you go about user interface buttons?
HTML. Yeah. We have a canvas. Don't try to do anything else. It's the best idea is just to use HTML DOM object. This is the best way to create UI by far. If you want to deal with 3D UI, that's a bit different. And we have what we call the pick. So scene.pick can allow you to know which object is under your mouse and where did you pick it. So you can use 3D UI. That's not really a problem, obviously. We can also support, I'm not sure the, let me try. We can also support video into your scene. So you can have some kind of video rendering into the scene, into texture, that's OK. But most of the time, when we deal with UI, 2D UI, it's just HTML5. That's the best way by far. If you look here, OK, this is a video. That's logical. This is a TV. So nothing really special. And obviously, the video is integrated, so you can feel the reflection and things like that. This is my home. No, I'm kidding. I would love to, but that's not the right. Oh, just this kind of thing in the main room. I would love to have that.
Do you support sound?
Sound, yes. The next version will be about web audio. We will add web audio, web 3D audio positioning, and this is version 1.14. Version 2.0 will be out with web audio.
Is the API going to change a lot in version 2?
No, well, never, ever. You can use the code you use with Babylonjs 0.9 and it still work. Excuse me?
Can you pick lines? Select line, not mesh line. Wow.
Not directly. But we can find a way. We should discuss about that. We have what we call internal data that you can access if you want to put what you want in it. But right now, it's not easy as I would love to.
Where do you define handedness? And can you change it to right-handed?
No. We are left-handed. And you have to, you have to use left-handed. But by the way, every tool that we are working on that generate Babylonjs do the translation for you. For instance, 3ds Max is right-handed, Blender is left-handed but Z up. We do everything for you just to be sure that the final Babylonjs is in the right format. If you want to create your own format or your own meshes into Babylonjs, yes, you will have to deal with that. All the computation. I cannot afford being able to test stuff like this into the shader, so that's why we decided to be straightforward. It will be left-handed, and I prefer offline modification of the data instead of being able to support so many different stuff live in real time. Thank you, everyone. I really appreciate it.